All right, get ready to go down a bit of a rabbit hole with me. It all kicks off with what has to be one of the simplest questions you could possibly ask.
So, someone actually asked an AI this very question. And look, it's a question you think we all know the answer to, right? I mean, we use numbers constantly. But, and this is the fun part, this one simple question ends up cracking open some of the biggest, deepest problems in all of logic and knowledge.
Okay, so the AI gives a pretty solid, common-sense answer. It says a number has to be a few things. First, unambiguous. 5 is always 5. It's abstract. The idea of 5 is different from seeing 5 apples. You've got to be able to compare it, do math with it, and this is a big one. You have to be able to represent it, write it down. Seems like a rock-solid foundation, doesn't it? Well, let's see what happens when we start pulling at a few of those threads. And right away, we hit our first little crack in the pavement. And the problem doesn't pop up with some super complex concept. Nope, it starts with something that feels totally obvious: identification. The question becomes, do you actually need to be able to identify a number for it to even be a number? And this is where things get really interesting, because it creates this split. For all of us, in our practical day-to-day lives, yeah, identification is everything. You have to see the symbol 5 and know that it means 5. But in the world of pure mathematics, a number can just exist. It's a theoretical concept, a point on an infinite line, whether we have a name for it or not. See? The ground is already starting to feel a little shaky under our feet.
So let's push this a little harder. The user comes back with a really clever follow-up question. Is x plus 1 a number? Now think about that for a second. Is that one single thing a number? Or is it three things: a variable, an operation, and another number?
This really highlights the difference, doesn't it? 5 plus 1 just becomes a single concrete thing, 6. But x plus 1, well, that stays x plus 1. It's not a number itself. It's more like an expression or a recipe for finding a number. But you can't cook it until you know the secret ingredient, x. So you see, our neat little definition is already starting to fall apart. X plus 1 is totally workable in algebra, but it isn't a specific, concrete number we can point to.
Okay, so at this point, the user decides to really dial things up to 11. They're like, forget abstract stuff like x. Let's talk about a number so ridiculously huge that it makes you question what it even means to represent something in the first place.
And this number, wow, it is an absolute monster. It's 10 to the power of 10 to the power of 10, 6 times. I mean, you literally couldn't write this number down. Even if every atom in the known universe was a tiny piece of paper, you'd run out of room. And yet, here's the kicker. We can describe it perfectly with just a handful of symbols. So the challenge to the AI is, can you add 24 to that? And the AI's answer is basically, yeah, sure, no problem. The result is simply x plus 24. And this is the key. Even though we can't possibly write out all the digits, the number is exact. It's identifiable. Why? Because we have a precise description for it. This gigantic number is what you might call cherry-picked. It's special because it has a neat little formula, a name. But that leads to an even bigger question. What about all the numbers that don't?
And boom, that's the question that just blows this whole investigation wide open. Think about it. What about all the countless numbers right next to our giant cherry-picked number? The ones that are just for all intents and purposes a random string of digits. The ones with no tidy formula, no short name. Are they still numbers? How can we even do math with them if we can't even describe them?
And this brings us right to the heart of the matter, to the central paradox of this whole thing, the clash between what a number is supposed to be and what we're actually capable of describing.
Okay, so get this. This isn't just a philosophical idea. It's a cold, hard mathematical fact. Just try to imagine all the possible descriptions you could ever write down. Every formula, every computer program, in every language that could ever exist. It's a ridiculously huge amount, but it is finite. Now compare that to the numbers themselves. There are infinitely more of them. So the logical conclusion is just staggering. The vast, overwhelming majority of numbers have no short description. They're basically just random noise, totally incompressible, and forever beyond our ability to name or even point to.
So the user comes back with this fantastic, sharp analogy. They ask, are you saying indescribable numbers are gnomes? And it's funny, right? But it's also a brilliant way to frame the problem. If these things exist, but we can never ever see them or describe them, how are they different from something we just made up?
So the AI, trying its best to explain, offers up its own metaphor. It says, okay, think of all the describable numbers, the ones we can actually name,
as little islands in a vast, endless ocean. They're real, they're there, but they're few and far between. In the ocean, that's all the indescribable numbers. It's a nice picture, it sounds good, but it has a huge, fatal flaw.
And the user calls it out right away. The problem is, the real number line isn't like an ocean with a bunch of empty water between the islands. It's a continuum. It is packed solid from one end to the other. There are no gaps. And because of that, the AI's whole islands in the ocean metaphor just completely falls apart. It doesn't work.
So let's take stock of where we are. We started with a nice, clean definition that said a number has to be representable. But now we've just seen that mathematics itself proves that most numbers are fundamentally indescribable. This leads us to a completely absurd question. Does this mean that most numbers aren't actually numbers? Our definition hasn't just frayed, it's completely unraveled.
And what this shows us is that the problem isn't really about the word number at all. The problem is much, much deeper. It's about the very act of trying to define things in the first place. The very tools we use to build knowledge, definitions, axioms, they are the source of the problem. I mean, think about the absolute foundation of logic and math. Axioms. What are they? Well, they're basically the unproven base rules of the game. They're the starting points that we all just have to agree on so we can even begin to build a system of thought.
But hold on a second. To understand that definition, you need to know what a base rule is. And what does unproven mean? Or formal? Or system? See the problem? Every definition just points to other words that also need defining. It's like turtles all the way down. You never hit a solid foundation, you just find this big tangled web of ideas that are all holding each other up.
And that right there, that's the big takeaway from this whole thing. The very second we try to draw a sharp line in the sand, the moment we say this is a number and that is not, or this is describable and that is not, we ourselves create the paradox. Our desire for these perfect, clean, black and white definitions, that's the real source of all the confusion.
So where does that leave us? What's the solution? Well, it's not about trying to find an even better, more perfect definition. The real answer is to completely change how we think about knowledge itself. It's about finding the wisdom in acknowledging our own limits.
You see, real progress, real breakthroughs, they don't happen when we pretend that our tools, our language, our logic are flawless. They happen when we get really honest about what our tools can't do. It's about understanding that our descriptions of reality are just maps, and it's crucial to know where the edges of the map are.
And this isn't just some abstract idea. This way of thinking has been the engine behind some of the biggest breakthroughs in history. Take logic. Russell's paradox was a huge problem until mathematicians accepted a new limit. Okay, not every collection can be called a set. That gave us modern set theory. Or math. Gödel's theorems prove that any system can't prove everything about itself. Accepting that limit revolutionized our understanding of logic. And physics. Progress absolutely exploded when scientists admitted that classical physics wasn't the whole story. It was just an approximation. Acknowledging that limit blew the doors wide open for quantum mechanics. Every single time, the great leap forward came from admitting that the old maps just weren't good enough.
So, we started with a ridiculously simple question. What is a number? And we ended up staring at the fundamental limits of human knowledge. This whole way of thinking, of really questioning our own definitions and being honest about what we don't know, it's an incredibly powerful tool. And it really makes you wonder, doesn't it? What other simple truths that we just accept every day are just waiting for someone to ask the right question, to peel back the surface and reveal a much deeper, messier, and way more interesting reality hiding underneath?